How does Bitcoin transactions actually work? How can I program money to behave like I want to? And how can we know that this is safe? How does Bitcoin manage all of this money in this decentralized system? That is what I want to show you today by digging deep under the hood of Bitcoin. And this is actually one of the lectures from the Bitcoin programming course, more or less. It's not the exact same video, but I'm going through the materials of one of the lectures in the Bitcoin programming course. And this will only cover a very basic Bitcoin transaction script. And if you want to learn all of the details about stack-based programming of Bitcoin transactions, of more complex Bitcoin transaction types like pay-to-script hash and multisig and segwit, all of that, you will have to join the Bitcoin programming course, which is linked below, or actually join our academy where you will have the Bitcoin programming course included. It's a fantastic course, one of my favorites. And I think why I'm doing this video is because one of the things that I found the best way that I learned about blockchains and cryptocurrencies when I got started was to study the Bitcoin blockchain and to understand how transactions, UTXOs, inputs, outputs actually worked and how it was controlled by this decentralized network. That led me to understand the entire ecosystem better by understanding the core mechanisms within the actual protocol itself. So that is what we're going to do today. And let me switch over here to the presentation. You probably already know about the basics of a transaction. If you don't, you have to Google or join the academy. You will take this from scratch in the academy. Here will jump right in. So in a transaction, if we simplify it, we have inputs, we have outputs, and of course outputs that are unspent, UTXOs, unspent transaction outputs, can be used as inputs into a future transaction. And each output contains something that's called script pub key, or a locking script, which defines or basically locks this transaction with a specific script until someone comes along with an unlocking script, that's also called script sig, that proves that the holder of that unlocking script was the rightful owner of that UTXO. So the script is made in such a way that, the locking script is made in such a way, the script pub key, that only the rightful owner of those Bitcoin would be able to provide a solution to that script. So what does a script look like? Well, we can take a look at a unlocking script, and or actually let's take a look at both of them. Here is a locking script that is coming from an output. The red one, that's a locking script, script pub key, and it contains some functions, opdup, ophash, ophash 160, and an actual hash. And then we have a function called op equal verify, and then function called check sig. So that is a locking script, and that defines a pay to pub key hash locking script, and that can only be unlocked by a user or a wallet that has the private keys to the public key that corresponds to this public key hash that is within the locking script. So if someone wants to use this output, they need to provide this unlocking script, the green one, which contains a signature and a public key. And this is then combined in two ways. So when all of the nodes in the Bitcoin network are going to check so that this input actually is a correct input, meaning that this provided the unlocking script that is the correct one. It's a correct unlocking script that actually unlocks this output. How do we check that? Well, we put the scripts together. We merge them together into first putting the unlocking script, then afterwards just merging it with the locking script. So it's just not one line of first the signature, then the public key, then these functions, dup, hash 160, the pub key hash, which of course was provided when the transaction was actually, the UTXO was actually created, and then equal verify, check sig. So this is now a long string of hashes, signatures, public keys, and function calls. So these two are combined, and then we execute them using the rules that is in the Bitcoin protocol. And that we do with a stack. So we have a stack-based programming language, and if you don't understand this, once again, you need to understand stack-based programming languages, and you need to understand how they are executed, but that is covered in the Bitcoin programming course. But basically we just go down this string, adding the variables to the stack, executing the functions on the data on the stack, and then if everything is correct, we will end up with the 1 on the stack, meaning true, everything played out. But basically we add the signature to the stack that came from the unlocking script, we add the public key that came from the unlocking script. Then the next thing is a op_dup function, which duplicates the top element of the stack. Then we execute the op_hash 160 function, which hashes the top element and then puts the hash of that on top of the stack instead. So now we have the hash of the provided public key. Then we add the next element in the script, which is the pub key hash that was provided in the locking script. Those two, you see, is now the same. Don't think about the color, it's just for clarification. Then we run op equal verify, which takes these two elements and checks that they are equal, which they are. Then all of that gets discarded. Then the last function is op check sig. That takes the public key that was left here and the signature and checks so that this signature actually is the signature for this public key. So we run op check sig on that, and that will put true or 1 on the stack. That means that this was actually a valid input because it unlocked the locking script of the previous output. So only the person that actually received this UTXO could have provided this unlocking script because it contained the signature and the public key. All right, so with that, I hope that you learned something today. This is how we actually control that unspent transaction output actually only can be spent by the rightful person. And this is of course not how we interact with Bitcoin on a day-to-day basis. This is all abstracted by wallets, by block explorers, and luckily we don't have to see this and code this ourselves because the wallet does so. But if you're interested in actually building a career within blockchain, actually working with Bitcoin and doing more complex transactions such as timelocked, such as multi-sig, such as pay-to-script hash, and learn how these different transaction types work, then you need to join the Bitcoin programming course, which is of course linked below, a link to our academy. And I hope to see you inside there. And if you have any questions, leave them in the comments section. I hope you learned something today. Thanks for watching. Make sure to smash the like button if you enjoyed this video, this type of content. Otherwise, you can hit the dislike button. Either way, get subscribed to the channel so that you don't miss any of my future uploads. Thanks for watching. I'll see you in the next video.